All right, here you go. Time to buckle in. All right, time to buckle in here. And I'm just, at this point in the unit, the excuses are over. It's either you're going to grind and find how to do it, or you can just live by doing that and getting no credit. Okay, and really that's not really the punctuation you want in an honors level class, right? All right, here we go. So go ahead, set it up. I'm going to start the same way I've been starting all these proofs. Go ahead, set it up, and then we have to figure out together what do I have and what's the deal with the proof statement. ER congruent to IT, ET congruent to IR. And I have a right angle here. Okay, let's look right at the proof statement. Are we at this point? Last day of the unit. Are we at this point when I see a proof statement saying two line segments are equal? I know I have to prove triangles equal. And I know my proof's going to end how? With the reason of CPCTC. But I can't do that unless I prove a pair of triangles congruent that contain TD and RO. So that's our first step right now as a class. We need to pick two triangles that we're going to try to prove congruent that have TD as a side and RO as a side. A little bit tougher because we got a couple options, don't we? We could prove the top and the bottom one because they contain TD and RO, or we could prove the one on the left and the one on the right because they contain TD and RO. Everyone agree? Are we all in agreement there? All right, so which pair do we pick? Well, how about this for a suggestion? How about pick the one we have the most information about? All right, because I think one pair I only have a pair of sides. The other pair I got a pair of sides and a pair of angles. So why don't we prove those two? Everyone see the two we're going to prove congruent. TID along with EOR. Is everyone all right with those two? And why? Because I can't lose you at this point, or I can't lose you right now because we're not even to where we need to be. Can't lose you here. This one, along with the one right below it. And again, I'm picking those two because they have TD and RO as sides, and I already know I have a pair of angles and a pair of sides. So let's see, TI and ER, there's my pair of sides. I say I have a pair of angles, but have I written them down yet? No, in step 2, I will have a pair of angles when I tell you that TDI congruent to ROE. Why? We got a test coming up on Wednesday. 11, why are those two congruent?
All right angles are.
All righty. And there is a pair of angles. So it's not that bad, right? I already got two. Now I need one more. I'm only going to give your group a minute to see if you can figure out. That's it. Just another minute to see if you can figure out if any sides or angles are equal. Go ahead. And 1 minute. That's all I can give you. 1 minute. If any sides or angles are equal.
So if I use RE,
You can't subtract because here's the problem. Let's say IE is 10 and DO is a length of 6. That means I have 4 left over, right? Well, not necessarily 2 and 2. It could be 3 and 1. Okay, so I can't subtract 2 reflexes. And I wouldn't write anything down.
No, we couldn't do that yet.
Don't think you and your group have it, so don't start writing stuff down here. But I'll at least give you another 20 seconds here to talk about it.
I don't think we
No,
need
that's it.
I know.
Wait, what is that?
Yeah, I mean,
Okay, let's get back to it. Any group find another pair? Any group find another pair? Look around the room. Anybody see any hands up? That's because there is no other pair. Right now in this proof, you will not find another pair of congruent angles or sides. Right now you can't. So does that mean this is impossible? No, it's not. It means we have to look elsewhere. All right, there is not a third pair of congruent angles or sides that you will find. So right now, we need to look away from these two and let's find another pair that we could prove congruent. Regardless of the proof statement, look for two triangles in this diagram that you and your group could prove congruent. Are there another pair? Because right now, there is no sides or angles congruent. We're stuck. You know what? We'll get back to them. Hey, we're not leaving them. We'll get back to them. But right now in this proof, there's no way they're going to be congruent. So you and your group right now, look at all the other triangles in this diagram and see if you can prove another pair congruent. Regardless of TD and RO, I don't care if they have them or not. Find another pair, because there's another pair out there that are congruent.
Oh, yeah.
Okay, but did you say it? No, you said it.
Alright, so ready for each.
We can do the in a triangle.
We can do O.
All right, let's move. Any groups find another pair? Nick, what you and your group find? Okay, so it looks like, everyone take a look, the two big ones here, TIE and ERI are going to be congruent after we say EI congruent to EI, reflexive. And now we do have a pair, not the pair we want, but we do, and it might help us. TIE, the triangle TIE now congruent to, oh boy, if I go TIE, what do you think, guys? REI. What's your method here? Side, side, side. What's he doing up here? Is he just making the proof longer so I can get more partial credit? No. The second half of this unit has been dedicated to, when I know two triangles are congruent, what else do you know now? If two triangles are congruent, what else do you know? Everything else is congruent, isn't it? Sides and angles are all congruent in those two triangles. Are there any sides and angles in these two that also are in the two we got stuck with? That'll put us over the edge. Are there any corresponding angles or sides that are contained in these two that are also in the two we got stuck on? 45 seconds in your group. Find a pair of sides or angles that are contained in both pairs of triangles.
Yeah.
You said TIE.
Oh, I thought you said T. I was like,
No, I said TIE.
And then CPTC. And
But
then
how is that TIE to REI?
All right, back together. Any groups find those angles or sides that happen to be contained in both pairs of triangles? Pedro, what do you got back there?
TIO is congruent to DER.
Everyone take a look at the angles I'm about to mark. This one, everyone see how it's in the big one and in my yellow one. This one, notice how it's in the big one and the blue one, correct. And now, how do you know those angles are congruent? TIE congruent to angle IER. What makes those congruent? CPCTC, because they're in the side, side, side triangles. And guess what now we have? You found the missing link. That was that missing pair we needed originally. So that's what's going to happen today. You're going to get stuck with the third pair. And the third pair is not going to happen until another pair of triangles are congruent. Now I have, I don't want to do different colors. Triangle, let's see, TDI. Congruent to triangle, if I go TDI, TOE. No, hold on. Those O's, that O and D is, we should put them closer to the vertex, huh? How about TDI? Congruent to a triangle ROE. And what method do we have there? Angle, angle, side. And now you have TD congruent to RO by CPCTC. Any questions there? So does everyone see the missing pair is going to probably come from another pair of triangles today? All right, let's go. One more, and then you got one on your own. Any of those angles I gave you help? In those two triangles, any of those angles help? What I mean by help means, are they actually angles in the two triangles I'm asking you to prove? Which pair? 3 and 4. So I'm going to put an A there. 3 and 4, get an A. Because that's a pair of angles. All right, let's keep, before we give up, anything else you can see on your own between those two triangles that I can write down? Come on, we're at this point in the unit. Anything else in those two triangles you know? 8. 8. I'm missing an 8.
QB is congruent.
Not a side in either triangle. So I can't count it as an S.
QB
Congruent too?
to QE.
Yep. Okay. 1 more to go. 1 more to go. And again, hey, no. There's nothing up there that says that. No. Congruent sides are across from congruent angles. No. They have to be, these angles are not in the same triangle. No. Good try though. I don't know what else it's going to be. I could give you the rest of class. Right? There's no third pair right now. There's none. So get over it. Get over yourselves. Find a new pair. Find a new pair now. Now look at the diagram as a whole. Are there any triangles I could prove congruent? Are there any triangles you and your group could prove congruent other than the 2 we need, which we know is impossible now?
You can say yeah, sorry. Yeah.
I don't know. How's there 2 pair? Where's the other pair? We only have angle side. Where's the other? Right? You can't count those. All right, everyone see the triangles? Which 2 triangles are we talking about can be proved congruent here eventually? After I add in a little extra something here. What's up, John?
QTB, QUB.
After I say what, though?
QB.
Yep, QB, I'll just add that in step 2 because it's a reflexive. And then, yep, now you have triangle QTB congruent to triangle QUB. What's your method, John? Yep, angle side angle. You know why we proved them congruent. Find a pair of corresponding angles or sides that are in these 2 and the 2 we're trying to get congruent. That's the toughest part about today's proofs. Go ahead, talk to your group. Find a pair of sides or angles that are contained in your angle side angle and your triangles we're proving congruent. Where is that CPCTC pair?
We need a bigger eraser. Okay. We need a bigger eraser.
You really want to break this flag with this like come on. No. I can't believe you want us to be like dispersed.
No, that's cool.
But it's drawing you.
Are you sure? You're really gonna miss that.
No way.
Okay, where's that pair of corresponding parts that I needed? Where are they? Where's the pair? Where's the pair that's in both? Nick? Yep, take a look. QT's in the big one and this one. QU's in this one as well. QT, congruent to QU. CPCTC. And there is the side I needed. And now we're on our way. At first glance, it doesn't look like much because it's only 5 steps, but we packed it in here. Why is those side angle side? We already said that. I don't need to ask you.
Yeah, because we're like 2 reflexes. Which one's reflex?
Any issues? All right, all I want you to do on the next proof, prove the triangles I asked congruent. That's it. And don't overthink things. I know we just did 2 where you had to prove 2 pairs of triangles congruent. Don't overthink it. That's all I want you guys to do is to prove the 2 triangles congruent, and that is it. That is it.
But we have to write down the ones we don't know.
This is just a visual, bro. I should send it to be a PG already.
Like, oh, you're ready?
Why are you angry?
That's it, just the triangles. Yep, don't move on to the second part.
No, just because it says bisects doesn't mean. Yeah, you have to like.
It said no. It said nothing about DG and GB. It says DC.
Just get the triangles congruent.
What am I doing?
I forgot what I was gonna say. I'm
What am I doing?
on the 8th, on the 11th.
This one.
No, next month. Are you guys excited for me? Yes. Thank you. Wait, so you guys did death of bisect, I remember. Maybe write down the wrong thing.
All right, did we get the triangles congruent before I help you out in the second part? What'd you do for the bisects part? What are you writing down because both bisect each other? 17, if they bisect each other, therefore?
The sides are congruent.
What sides? Go ahead.
CG
With?
and GA.
Good, and?
And then DG and BG.
Perfect. Perfect. DG congruent to GC. And nope, DG congruent to GB. Try that again. And GCG congruent to GA. Where the other pair of corresponding parts come from. Maybe you probably couldn't see it. It's a little magic eye trick here. I think maybe FE, that segment was getting in your way. Little math magic here.
Whoa.
Whoa.
Oh my god.
Do you see it now? They have what? Vertical angles, right? Angle DGC congruent to angle AGB. Vertical angles are congruent. And there's your A. And now we are good to go for the triangles, I hope. Triangle DGC is now congruent to BGA. What do you got there? Side angle side?
Yeah.
All right, everyone ready to help me with the second part? This is how I know if you know what CPCTC really means. Can I just go step 5? These two are congruent, CPCTC. No, that's not how CPCTC works, because these two are not sides in those two. That's the only way I could use CPCTC, and they're not. So, all right, well, we're still going to have to get GE and GF congruent by proving what? Pair of triangles. Okay, so as a group right now, let's pick a pair of triangles that contain GE and GF, and let's get after it. Probably not. Let's not pick these two here or the other two next to it. I don't have anything. How about you pick some two triangles that you got info about? So one person is going to represent all 28 of you. 11, pick 2 triangles for me.
So proud to represent everyone. DEG.
This, I don't think it goes the other way, but go ahead.
DEG.
Yep, you want to do this one with?
Yeah, it's BFG.
Yeah, I didn't care about the order, but thanks.
Oh.
Yeah.
You're welcome.
We could get those two, or the other two. They're both doable, just not the ones that are stacked on each other. All right, so Brody picked those two. I'm okay with it. The only thing I'm not okay with is I only got 1 pair of sides. I need your help with the other 2 pair. All right, we see right off the bat, John. Oh, no, don't, no. I don't want that yet. I want the basic one of them. Don't get advanced here. I don't want that yet. Name the other pair. Vertical angles are congruent. Thank you. I think that's where most of us could get right off the bat. Angle DGE congruent to angle FGB. Vertical angles are congruent. Good. So we have a pair of sides. We have a pair of angles. 1 more pair to go. Hopefully nobody listened to what John said first. 1 more. It was correct. I just didn't want to reveal that because that's the toughest part about this and what has to make your classmates think. Where's the other pair going to come from? Hi. Remember, you just did that all by yourself. And that means every single corresponding angle and side in those are congruent as well. Do their parts have anything in common with their parts? Turn it back to you and your group. Do their parts have anything to do with the triangles parts we're trying to prove?
On what? I know it's what? Oh, yeah.
Yeah, they're found.
Am I the only one who's not happy?
You go with this one.
I don't like I was kidding. That was sarcasm.
Guys, we still gotta finish it.
All right, those parts. All right, now I'll let you have your glory, John. Go ahead, have your glory. D congruent to B. If anybody's losing me here, look, D. See how that is in the big triangle and the yellow one. And B, that's in the big triangle and the blue one we needed. So yes, that's the pair by CPCTC. So basically from here to here we went. And then finally now, you got enough info, triangle. Go ahead, now you can name them.
Oh, DGE. And
You screw this up.
That's not,
I said
and
don't.
BGF.
BGF, yeah.
Yeah,
Icing on the cake, how about a little method there, Brody?
It's
It rattled.
I got it. Angle side angle.
All right, there you go. You had a 20% shot, so.
thinks he knows.
And then GE congruent to GF. CPCTC. As you start the couple proofs on the assignment, hey, anything goes. This is a mixed bag of proofs. It is now time to start reviewing for the test. So I do not want you to get in the mindset of, oh, I'm going to have to prove a pair of triangles congruent to get another pair. No, this could be anything. Anything. These proofs could be anything. Overlapping, anything. So you and your group or you by yourself, let's keep going. If you get stuck, call me over. If you want me to check your proof, don't call me over, get on Classroom. But if you get stuck, let me know.